So when we have our nickel resin, what nickel resin refers to, or the product that we have, uh, it usually resides in some sort of a column, right? And the nickel resin in this column here, if we were to draw a little cartoon of it, it would be some sort of plastic material, and on the surface would be an EDTA moiety, EDTA, covalently attached to this little piece of plastic here. So we'll draw this EDTA moiety kind of like a little claw, all right? And when the nickel resin is charged, what it means is it has an atom, an ion of nickel bound to that EDTA moiety. This resin has thousands, hundreds of thousands of EDTA molecules on the outside like this, right? Okay. So when we introduce, if we put over this column here, something like, 0.1 molar EDTA, all right, if I put 0.1 molar EDTA over the resin, so this is where our resin is, our little beads, right? So all this is in here. When we put EDTA over the resin, what it does is the EDTA comes down. Now this is EDTA that's not covalently bound to any plastic, right? It's just in solution. But the EDTA will grab on to the nickel. So we'll have the piece of resin here. And the nickel is now being bound by EDTA in solution. And that nickel, then, because that EDTA is flowing down, that EDTA will move down with the nickel. All right. Now, as it gets down further on the column, it might be that a different piece of EDTA resin grabs it back, takes it back, right? Because there's not necessarily a stronger affinity of that nickel for this one or that one there. It's basically the same. But it can grab it for a second, and because this EDTA is moving down, it can pull it off there. Or what can happen is it gets pulled off, and then another molecule of EDTA can grab that nickel away. And that will, if you create a concentration of molecular EDTA in solution, not the one that higher than the amount of EDTA that's actually bound to resin, then that nickel will be busy being entertained by the other EDTA molecules, and we can what we call strip the column of nickel. And so what will happen is we'll essentially have our resin here, and all of the EDTAs will be free, and there will be no nickel in them, no heavy metals. There is going to be other ions to balance those charges, and those will probably be whatever the counter ion was that you had for EDTA, like hydrogen ions or sodium ions. We were sometimes using tetrasodium EDTA or trisodium EDTA acid, right? So whatever our counter ion was would be what would be left behind entertaining those EDTA molecule entities, because they're charged, right? But those don't bond very strongly. It's only the heavy metals that bond strongly to EDTA. So when we poured our water sample then over our EDTA resin segment, the EDTA would pull out any heavy metal ions and bind them. Okay? So hopefully that video kind of clarifies the relationship between the nickel, which initially starts on the resin, us adding EDTA to pull it off, and then leaving it primed and ready to take metal ions from your solution that you want to clean up.